Director. I did my little part. I appreciate
No, if you don't approve it, I can't record. Thanks for reminding me, Thomas. Um, I probably didn't record Laura's either. I think I forgot to hit record. You let me forget, I think, last week. So who's next? Uh, Damon, you were working in R, right?
Yeah, that's correct.
You got a little something to show us?
Yeah, I do. Hey, one.
Oh, and Gabe, if you wouldn't mind emailing that out to the group and everybody just store that in your functional notebook directory. Examples. Mm-hmm.
All right, is that showing?
Yes.
Okay. So I found a data set on Kaggle called Mental Health and Tech. One second. Let me try to move some stuff around on my. There we go. So yeah, the problem with I kind of found out with this data set is that it's more just about everything that was in the table was categorical data. So it kind of gave me some issues when it came to graphing some things out and whatnot. But so just kind of jumping in here, you know, I think everyone's starting to recognize the importance of mental health and whatnot. So this data set seemed pretty interesting to me to kind of see how employers are incorporating that into sure and just how they're supporting their workers in this way. So one of the questions I wanted to ask was, do countries, sorry, I misspelled something. Do countries play a role in the anticipation of negative consequences for discussing mental health? To explore if there are any differences in just countries when it comes to this, to the responses. Because I did it in R, it's kind of hard to copy and paste the data set into. These are some of the the variables that were included in the data set. So we got like state, age, gender, country. Sorry, I should have formatted this a little bit better. The benefits. So the one thing that I was just talking about was that mental health consequence. So do you think that discussing a mental health issue with your employer would have negative consequences? And I wanted to look at that across the different regions, well, mostly a country. First question. This important data section, these are just packages that I use in R. All of these weren't really necessary for what I did, but I don't, with R, in one script and just put it on a new script. So I usually am just carrying them around. I'm not super familiar with which ones do which. So yeah, and this is kind of how it gets read into Python is. I tried again with Python down here, and we can see that the little timeout error or name error and whatnot. But I think that's because pandas just wasn't loading for me. Yeah, so first question, do countries differ much in expectation and negative consequences from discussing mental health? So I did a count using that table that I imported. I did country, because I wanted to find which countries were like the most, I guess, appeared the most in the survey. And I chose the top 3 because a lot of these with just one and whatnot, I didn't think would be super helpful. It wouldn't be a very good the US, the UK, and Canada. So yeah, the US had 751, the UK had 185, and Canada had 72. So after that, the main data set for where it equals the United States or the UK or Canada, and I had the majority of the original observations there. So after that, I used Dr. Worley's, I think that PDF that she gave us was super helpful. It kind of gave me some, I guess, some tips on how to use like a table and get things to appear as percentages and whatnot. So the first thing I did was just kind of a table, I guess. So for Canada, you can see, you know, people who wrote maybe for, you know, discussing with your employer that you might have, well, anticipating negative consequences from discussing with your employer, like mental health issues, you know, and so on. So the UK, the United States, and whatnot. And then I kind of put that in a percentage to kind of make it a little bit easier to, I don't know, discern. And big difference between these 3, at least. You can see like the yes for the UK, which was the most, was like 23%, and then the US was 22%, and Canada was also 22%. So not a lot of major differences here. Oracle data. I tried to output some like box plots and whatnot, but it didn't really fit super well. And then also trying to copy a graph that I put in R into Jupyter Notebook just did not work whatsoever. So limitations here. So kind of moving on to the next question. It said, are there any major differences between working in tech and non-tech? So I wanted to just kind of look into that because that's what I guess the big thing was about this data set. It was mental health in tech. So again, I had to use the table to kind of crank this out. And based on these percentages, it didn't seem like there was a big, I tried to use the chi-squared statistical test because that one works well for categorical variables. So established a p-value of 0.05, 95% confidence level, things like that. And the null hypothesis I set that whether or not the company is a, as a tech company, is associated with observed consequences. So it's pretty much, have you heard or observed, I think it's pretty self-explanatory. And then the alternative hypothesis is that they are associated. So ran that in R, and this is what it kind of spit out here. The p-value is what I used to make the decision of whether or not they were associated, they're correlated. I think those are pretty much the and because the p-value that we got from this was less than 0.5, well, 0.05, we can reject a null hypothesis. Then after that, kind of did a similar thing. Again, I'm sorry, I don't really have graphs here, but I think after I finish this section, it might make up for it a little bit. So here we're just kind of talking about the differences in the ability to take medical leave for mental health conditions, again, with tech companies. I was not able, did not run a chi-squared on this one. So again, this is just kind of like the tables and kind of looking through, there's not major differences in here. They're mostly within, I guess, 3% of each other. Some are even less than that. And then I differences in like a wellness program to see if there was a major difference between like within tech companies, well, with tech companies and non-tech companies. So yeah, kind of a big difference here, but not really wider than the other ones were. Let's see. And the last thing, wait 1 second. That one already. Yeah. I'm sorry, this is kind of it's kind of a pain to try to transport this stuff into R, so it was, I don't know, it's not as clean as it would have been if I had done it in Jupyter Notebook. But the last thing I want to show you guys is what's called a sunburst. So let me kind of pop over here really quick. So this visualization I have, but so in the data set, there are 1,259 people, and I kind of coded this out to be able to, I guess, almost like a rote in a way that kind of shows how the proportions, I guess, of the individuals in the data and their different characteristics, I guess. So you can kind of see, like in here, going off of the root, you can see how many.
Cool. What do you call this thing?
Yeah, this is called a sunburst. My boss discovered it about a couple weeks ago. We were trying to figure out a way to present a lot of information in a very condensed way. And this is kind of what we've been using as opposed to like normal graphics and whatnot. You can kind of see how, I guess, what's a percent of the overall total and how many are involved and whatnot. And it doesn't take a lot of code. I kind of.
Well, what is it? How, you know what I mean? What are we looking at? We're looking at an HTML document that looks to be an interactive visualization. Oh, there it is. That's the code that created this. Cool.
Yeah. I wanted to jump to the visualization to show you guys what I was talking about before I kind of to the code. So I just choose the variables that I want to look at, and also I think later on down here in this step is when I kind of determine the order of those. The answers in the survey were like yes and no and never and sometimes and whatnot. So when it actually gets into the sunburst, it just, these sections would just say yes and no and whatnot. So it didn't, you know, what you're looking at. So when I'm doing this, the first part is to select the variables that I want to use. And then the second part is to recode those answers to something that's a little bit more meaningful, so you can understand, okay, the treatment variable, so sought treatment, no. So when we're going through that, I guess, I don't know what the word, a good word for it is, the steps over here off to the right, you can kind of have a better idea of what you're looking at. So Out of the 1,259 people, 622 of them sought treatment for a medical condition. Well, did not, because I put no at the end of that. And then let's just go down here and make it a little bit more simple. So 622 on this side, and then the 637 on this side. So you can kind of see how it makes up the entire circle, you know, and then you kind of keep different rings, and it shows you just a deeper, you just kind of get deeper into the data as you go further out. Does that make sense a little bit?
Yeah, I was looking at the library that does these for Python. It's called Plotly, which I've seen a couple of different times. But I apologize, Damon, if you were talking about this. I was trying to catch up with how you did it while you were showing it. The actual write statement that saved the sunburst out as an HTML file, where is that? Down at the bottom of this code set?
Yeah. So after I recode all those things, it kind of, let me see if this is, yeah. So I recode everything. I use the count the count function, and it pretty much just, I might show you guys that in a second. It's a little bit easier to show you in R than try to explain it. But after everything is kind of formatted with this count statement, the frequency for all of the different combinations, that's a good word for it. So that count statement will find the combination. So treatment, you know, yes, no, pair it with the word like interfere, and then it'll find all of those combinations and give you the frequency for all of those. But to use this this function, this D3 nest here, and the sunburst, well, mostly the D3 nest, you have to rename on the size. So that's what I'm doing here with this line, and then I null out the frequency column. I just get rid of that. So this right here creates the sunburst. And there's two different ways it can kind of be spat out. So with this first one, my boss and I really don't use that one because it doesn't create this this over here on the right that you're seeing. It's it doesn't really describe the path that is like taken, you know. So we usually use the and yeah, once you use this first line right here, and then you jump to this line right here, you pretty much just call the name of it, and then it'll, in R, would pop up over here in this window, and then I as a HTML file and just save it to my desktop, and it'll open in Google Chrome. And yeah, the only unfortunate part about this is that you can't put it in a PowerPoint or anything like that because it's an HTML file. So yeah.
Well, if you wouldn't mind, Damon, first of all, I mean, if y'all don't mind getting emails, but for me, I want to try and get this running on my PC because I've got a dual Python R environment setup. It's called. You use your Anaconda kind of administrative dashboard to set up multiple environments. Like if you wanted to use Python 2 version 2 instead of version 3, you could set up you can set up multiple environments. And I've got one where I can create R or Python in Jupyter Notebook just the same. So I want to try and get your code running. But then if you could also upload this HTML document, I want to see if there's anything, any dependencies on your computer that require this to run. Are you familiar with what the D3 is that you're calling and how this works?
Yeah, so those are just these packages. I think that's what you're asking. So the library function in R is to load installed packages. Usually I'll go to packages over here, and then I'll hit install, and then I'll install what I need. And then after that, I can use library and then call the package, and it'll just load. So only those three. I can also pages that talk a little bit more about yeah, the Sunburst package and how to use it and everything like that. But I think it's a pretty powerful tool. I want to show you guys that because I don't create some visualizations like everyone else did with R, because, and this is probably something I need to kind of work with you on, with you, Don, on just categorical variables and like the different graphs and just kind of how to wrangle that. I'm sorry.
Okay. Yeah. Just let's set up some time. But what I wanted to talk about was what I know about D3. When we had, and I apologize if my audio is cutting out. I keep getting told my internet is unstable, and I've turned off my camera so hopefully I'm coming in clear. But anyway, D3 stands for data-driven documents, I think. And it's a super cool visualization library thing, kind of like pandas and whatnot, but it's made for visualizing on the web. You'll see, I've seen them, like, if you go to a COVID website or whatever, it'll say visualization powered by D3. So it's a JavaScript, which is another programming language, just like Python or R or anything else that's used in web pages. It's a JavaScript library that does all of this super cool magic. So I'm gonna geek out as much as I can with what I'm learning from you. But Plotly looks like it does kind of more static sunbursts. So you can do a sunburst in Jupyter Notebook, but I don't think it'll be as interactive as this unless you pull in. There's got to be a way for Python. If R can do it, the folks in Python, won't let that rest.
Yeah. No, that makes sense. Yeah.
So I'm gonna figure out how you can, because I know you can do things in Jupyter Notebook that are kind of interactive because it is a web page. Your Jupyter Notebook, rendered in the browser, it is capable of any of this kind of stuff. So this was super cool. I'm gonna try and figure this out. But yeah, if you'd email me your R source code, your .r and anything else that you got, I'm gonna try and get it running on my computer. In fact, you don't need to email me. Just upload it to the assignment.
Okay, no, that's perfect. I can do that.
I'll download it. No, this is cool.
And the last thing I kind of forgot to mention, sorry, is that you can click on any of these and that will become the root, which is kind of cool. Looking at the whole thing was a little bit overwhelming. You can kind of jump into any one particular section of it, and like I said, that'll become the root over there, and then you can kind of look at everything that comes after that as a percentage of the root. So yeah, that was just kind of, yeah. I'm sorry that wasn't as put together as it should have been. Sorry about that.
Hey, that's fantastic stuff, and that's the difference between. This is a professional peer-to-peer work group that I'm facilitating. This is not like a college class where I'm up here at my lectern and I'm preaching or confessing. No, that's cool stuff. I've just had so much fun, guys, nerding out with Python lately. Just trying to get stuff to work and thinking of oh, that's cool. How would it look if I did this? Change the things around. I'm working my way through a Seaborn tutorial that that is like a notebook, kind of like we've been doing for, but it's like 14 notebooks just on Seaborn. And of course, you got to have, Matplotlib underneath it. Um, so learning more about Seaborn. I'm coming up on break. Before we go to break, can somebody volunteer to be next? And it doesn't have to be put together. You just show us how you're doing. We got to have somebody go next.
I can go next, but I'm definitely finished.
Okay. Gabe it is. When we come back from break at 9:30. Cell phone time. Hey, Damon, can you hear me? Are you back?
I'm here.
I wanted to show you what I'm talking about here, and I need you to walk me through a hello world in R.
Okay.
Okay. So over here, can you see my whole screen?
Yeah, I can.
Okay. Over here under Anaconda, if you pull up this Anaconda Navigator, you can create another environment, and in that Navigator, I created an environment that included the R and Python, because I have R and RStudio on my PC, so I could do it. So in that environment, it gives you a shortcut automatically, so that for every environment you create, you get a shortcut here. So all I did was click on that, and it looks exactly like Jupyter Notebook, except I can say new, and I see here where I can say Python 3 or R.
Yeah.
So I'm going to click on R and make an unnamed notebook somewhere on my hard drive. And you see, you got the R logo instead of the Python logo.
Yeah. Now, one more time, you clicked on Anaconda and you were able to create a new like instance, right, of the notebook?
Yeah. If you Google it, I don't think I have it. Guitar stuff and coding stuff, the two great loves of my life.
Most important thing. Yeah.
Let me see if in my Python link, no, I don't seem to have saved how to do that. But if you Google it, if you, and I will too, I'll be able to find the web page that walked me through setting up a second environment, because by default you get one called root, and everything you do is in that environment. So what is the syntax for an R hello world?
Oh, I think it'd be just print, open parentheses. You can use single quotes or double quotes, and then hello world, and you close the quotes and the parentheses. And
just like Python?
I think that the major differences I've noticed are how you read things in. They're very similar, except with R, we'll use an underscore in between like read and like CSV, whereas Python uses a dot. So just very between the two, but mostly they're pretty pretty similar when it comes to things like to tables and making graphs and whatnot. I think the overall structure is pretty similar, but the syntax is what's different, which is why I wasn't able to follow the stuff we've done in Python so closely,
Yeah. And did I get that assignment? Is that the that less than or dash that assigns this is a string to A, correct?
Yeah, exactly. So that is just kind of like the arrow that you create, and that is how you assign things as opposed to an equal sign.
Yeah, there you go. So this is R, everybody. I'm actually running R without having to learn a new environment, because there's a thing called RStudio that's kind of like SQL Workbench for R programming. You saw it's called an IDE, Integrated Development Environment. The big one that everybody uses for Python is called PyCharm. Anaconda comes with one called Spider. They're a great way to work with Python, particularly if you're just automating stuff. You're just creating a Python program, not a Jupyter notebook with the interactive back and forth kind of with markdown cells and all that. But so I can save this, like, or rename this notebook like our demo. Rename it. So now we got an R. I have an R notebook somewhere that's probably on the root of my hard drive. And I can go up here and still, don't pull that down. Go away. There we go. I can go back to Navigator, and now I can still create a Python notebook. And you see, now we get the Python symbol up here in the upper right corner next to log out. So Jupyter Notebook using the same cool documentable aspects of Jupyter Notebook, but you can do your code in R or Python, and then you can do all the same stuff. Damon, you can like export as a or save as a PDF or whatever you want to do. file.
Nice. Yeah.
There's an export somewhere.
I'm happy you showed me this. Yeah, I'll have to check that out.
As. There it is. Download as. And then Markdown is its own thing. There's just a bunch of stuff to learn here. So
I saw the Markdown stuff at the end of Dr. Worley's intro to our PDF, and it was after our notebook. Is that right?
You cut out for me for the longest time. I'm not going to try and cover anything. My internet is flaking out for some reason.
No worries. It's all good.
So I didn't hear your question. You want to try again?
But I was just saying that I saw Dr. Worley's on Dr. Worley's intro to our PDF. At the bottom of it, she was talking about our Markdown cells, our Markdowns, and it was kind of our Jupyter notebook, but I was curious if that is like a Markdown thing is ours version of a Jupyter notebook. It seems like you could put comments in there and everything like that.
Yeah, kind of. I think an MD file is kind of like that. It's a self-documenting thing that you can then distribute, kind of like a notebook, but not quite. But Google it. I'm sure there's a world out there to talk about how to work with our Markdown.
All right, I'll check that out. So thank you again for showing me this.
Oh, cool. I'll I'll look up. I'll try and find how to create. It was called I know it was an R tutorial. That's why I named the environment R tutorial, because I was going to take an R tutorial, and I got a little bit through it. But how to create environment. Okay, Gabe, that was you that said you were going next, right?
Yes.
All right. Take it away.
Okay. Like I said, it's not very pretty. What I'm trying to do is find the difference or some, I guess, in the guns sold and the permits given. So permits versus guns. I brought my stuff over from BuzzFeed. There's a lot of it. And then brought it down to the permits given by state. There's some of the lines. And then we took out the territories outside of the US, so District of Columbia, Guam, and then we brought it down to the permits again, given per state and by year. And then the sum of them all. And then I tried to find the null, so the states that didn't have any permits given, but it came out incorrectly. It only gave me 24 lines out of 1,400. So I got to go back and figure out what went wrong there.
What were you trying to do again? I apologize. My internet is just really letting me down today.
And I was trying to find the nulls out of all the permits. So all the states that didn't give any permits. And I know it's wrong because there's one right there and there's no Alabama. It's got two actual states and then the outside territories.
Were you trying to eliminate data with nulls in it, or what?
I was trying to see which ones didn't have any at all. So I was trying to list which ones had no permits given.
Well, that would be where count of that column would equal 0. I would think that way, whether it's a 0 or a null, it would still
bring it back.
Be a 0. Yeah. If you want to write that up as a question and email me your notebook again. I'll take a crack at it.
Okay.
Just be real clear what you're wanting to do, so I don't go down the wrong road.
I was gonna do all the same things with the totals, so I copied the code and I took the states that we didn't need or the territories that we didn't need out, and then I was gonna find the difference years and then do the nulls there too, but that's where I got to. So the total number of sales, and then I was gonna try and figure out from one year to another what the difference was. So from 1998 to 2001, I was gonna find the difference, but haven't gotten that far yet.
All right. Well, if there's anything I can do to help, write up what you where you were going, what you wanted to do, and be real explicit. And if you'd like, I'll take a crack at it again. For me, this is fun practice, helping you guys.
Okay. I will definitely take you up on that.
Cool. Last year, I did a really cool, you know how you can refer to, let me turn on my camera so I can talk with my hands. You can refer to a data frame by column and row, by like DF open square bracket, column name, square bracket, row number. So like you can a cell in Excel by giving it the column and row. And you can for loop across columns and then down rows. And I did, so you got 2 for loops, one that goes across every column. And then for each time you do that, you go from row 1 to 2 to 3 to 4 to 5. And you can do anything once you're, going from left to right all the way through the data frame and from top to bottom. Once you're in the data frame, you can do any of the if then else logic, or you can create another column that is a calculated column based on the value in the row, and any stuff like that. And so I helped Xander do something like that to decide when to order more cans for beer at Lost 40, which just the fact that it had something to do with beer was good for me. But yeah, let me know if there's anything ever that I can do to help. I may not be able to. Some of this stuff is, I spend sometimes an hour or two on getting a single line of code to work the way I want it to. But a lot of times you come back to it. So anyway, who is next? No, I know I helped a couple of you. Chase, did you make any more progress?
Trying to kind of streamline my question a little bit. I got your edits. Just trying to clean it up some. So I'd rather not share at this time, but
well, I'm not gonna put anybody on the spot. I've got a couple of things I can go over that I want to go over, but I'm worried about my internet. Have I cut out at all, Laura? You're the only one with your camera off. Have I cut out my audio?
Yes, but my internet's also being weird, so I don't know if it was me or you.
Okay. Well, I'm having to call by name now. Okay, thanks, Gabe. So I know I helped Chase a little. Thomas, how you doing? Thomas, can you hear me okay? He might have had to step away. Okay, guys. This is something we need to knock out. I want to be confident that you can open up a data file as a data frame, and then run some quick statistics, correlate some columns, um, throw up pie chart, bar chart, line chart, whatever it might be, just so that your takeaway is that you can do Python data visualization. So if my lack of boundaries on the assignment is what's causing you trouble, I can just let me know. Shoot me an email if that's what's keeping you from having turned in something and shown your project. Just shoot me an email. Let me know what's holding you up, and we'll work through it. If you need something much more specific, like open a certain data set and run this kind of plot on these columns, I can do that for you. So let me know, but please don't, please don't let this go too much longer here. I want to make sure that we're all up and running with just some basic charting in Python. But there was let me go back to the classroom. Screen, share everything. So don't really want to close and halt. Don't really care about that one. In the classroom. Modules. So in Canvas, I added some notebooks. You don't have to download them right this second, but for some reason, I added strings and dictionaries. I don't believe you guys had those in there yet. String number 12 strings and number 14 dictionaries. When I went through number 12, and you need this CSV, Boston Housing Small, to go through everything in Notebook 12. We've worked with strings before. Some of the stuff in that Notebook 12 looked familiar, but when I looked on the classroom, I had never posted it, so I think I skipped over that. But that's a good notebook, and you can plow through it on your own. The main thing about it is string methods and string slicing that allow you to grab just the first 4 characters of the column, or break it on a certain character, like if you wanted to break a column on a comma or something like that, or break a string. So those things operate on an individual string variable. So I'm going to let you guys do that one at your own pace. But I did want to make sure that we go over the concept of dictionaries, which I've alluded to. We've talked about them a little bit, but I want to make sure that that you guys go through this dictionaries notebook, because we're starting to see them as being, it's not a data type. A dictionary is really a data structure. We're starting to see them more and more in pandas, in screen scraping, in API calls, in all of the more advanced panda stuff we're doing. So I just want to go over that one real quick. Number 14, dictionaries. Okay, so the main thing a dictionary is just like a list, only instead of referring to it, it's like a list or a tuple. Only instead of, to get to each individual value, you don't use 0, 1, 2, 3. You don't use the index number of the item. You use what's called a key. The key is the lookup value, like name. The value would be Don Walker. So a dictionary is a list, lowercase l list, of key value pairs. Okay, so beg your pardon. Easy enough. Get down here to your first code cell, and the syntax for dictionary is the curly bracket, and then very much like we've seen with other things, where like string slicing, where you have the colon notation, you put the key and the value. The key is 1, the value is John. The key is 23, the value is Eric, and so on and so on and so on. And that's the assignment statement, where Python automatically recognizes the syntax and creates a dictionary. Or you can put things, offices is also a dictionary, and you're putting it on the same line. John is the key value for COB 201, College of Business 201, Eric at Wingo Hall, which these are all on UCA, because of course this is one of Dr. Ellis's notebooks. So these are, facilities at UCA. So we create 2 dictionaries in that first cell. And I just ran it, and sure enough, it didn't print anything. But so now we want to get the number of elements in a dictionary. You print the len function, which is short for length, the length of the dictionary. We've got 3 for offices. Let's 5 for employee. So that gives you a number to shoot for if you did want to loop through the dictionary, a set number, from 1 to len, you could do it. And then down here, of course, we're not using the print statement, so each one of these overwrites the preceding one. But you can refer to employee 1, because 1 is the key to John. That'll bring back John. Employee 4 is Terry, and they don't have to be in order. There's no requirement for the keys to be in numeric or alphabetical order. So if we comment out the first one, we see that employee 4 brings back Tarek. Comment that one out, and offices of Eric uppercase, which is good because these are case sensitive, as most things are, like column names in a data frame. The key is case sensitive. So of course, but then of course, if we misspell, because Python's not smart enough to guess that we just left off this lowercase e, it doesn't know. You know what I mean? It doesn't know the difference between a capital and it's a different character altogether. So, bam, key error. And we're seeing that. You'll see that a lot whenever you're working with these more complex data structures, because they use dictionaries so much. Okay, so that's how you reference each individual value in a dictionary. But we can use if then else logic to test to see if a key value is in the list. So here we got employee 2's not found, but we know we got an employee 4. Rerun that. Oh, that ain't right. Oh, heh. Got to change it in my if statement. Duh. There we go. So if that key is in the dictionary, it's what that piece of code does. But you can also see we have employee names basically are the keys up here for offices. So if Graham in offices, print which office he is in, and of course he is, and then we got, I think we got what, Terry. Print offices for Terry, and you definitely don't want to get these mismatched because you'll print the wrong thing for. What happened to him? If Terry, and don't we have a Terry in offices? We don't. So we got a null return, a blank. Because there is no else here. So who was our guy up there? Eric. Let's go, Eric. If Eric in offices, print offices, so Eric. So there was no Terry, so of course it didn't do anything because that's how an if statement works. Wingo 107. There we go. Okay, and we can loop through a dictionary, loop from beginning to end. I don't think this word key is a reserved word. I think that's just the variable name, but we're going to test that theory here in just a second. So for key in offices, print what the key is, because it's returning the key as a list that it can loop through, not the value, the key. To get to the value, you gotta use the dictionary name, open square bracket, key, kind of like you would in a list or a data frame, And then we print a blank line. I put that in there. And then for emp in employee, print emp and employee emp. Yeah. So it's just basically going through both dictionaries. But I want to see if key is not a keyword. Yeah, he just used that word. I just didn't want you guys to get the impression that you needed to use the word key because we're using a dictionary. Okay. Adding or changing elements. Dictionaries are not like tuples, which you can't change the value of of a cell in a tuple. If you remember that from what seems like 100 years ago. But dictionaries are mutable so that you can change the value inside at a given, and again there's the syntax for a particular cell, call it, I guess, value in a cell is a dictionary, open square bracket, and then the key value. So we added Connie to the end of the dictionary. And another way is to Yeah, just in separate assignment statements, you can load up a dictionary like that if you want to. I don't see that so much out there in the Python universe. But there's also this dict function will I've seen it being used as like a converter, but you can create an empty dictionary like that, so it doesn't have to figure out the syntax, based on the syntax. So that creates an empty dictionary, and that creates an empty dictionary. And then, of course, whenever you mention an item in the dictionary for the first time, it just creates a new cell or a new entry into the dictionary. Yep. And to change a value, you just reference the cell. And you can use the del function. What else did where we use the del function? That was to delete, when we deleted rows, didn't we? Out of a data frame. I want to say we used the del function to get rid of rows in that data frame that was like Marianas Islands and Guam and Puerto Rico for the gun permits. Is that correct? Is my mic on?
I don't know if that's correct.
Okay. Well, I won't belabor the point. So yeah, if you delete something that doesn't exist, it's going to say you're going to get a key error. There is no nobody in the dictionary after you delete them the first time. Okay, and you can mix and match data types in a dictionary, and a dictionary doesn't have to be nice, simple, tidy data types like integers and string values. A dictionary can be a list of lists, and you've got a key value for each list. So here we have a Python list, remember, which is mutable, is changeable as opposed to a tuple. And we can print those out, and then you can inside of the dictionary, just like inside of a Python data frame, you can loop through a list that is within the dictionary. So you could, we could code this up so that it looped through each of the scores for John, Graham, and Terry, and then printed out the scores for each one of them. Because the dictionary is iteratable, right? It's a list that you can do, you can loop through. And then if each element is an item you can iterate through, then you've got a loop inside of a loop. And if you remember back in Looping 101, they get complicated. Okay. And Mike says, one of the most beautiful features of dictionaries is the values can be of varying data types. Oh yeah. It's just like a list. It's each item in there can be a different data type. And sure enough, this link still brings up this good old Stanley toolbox. The keys can be different types, and as long as they're immutable data types, string, integer, float, or a tuple. So you couldn't have. Good grief! I'm trying to think of how that would even work. How would you use a list as your key value? I would think it would need to be a tuple with one member, in it, which we kind of talked about when I was querying data out of the database with SQL. A tuple doesn't have to have multiple numbers in it. Well, I'm going to have to think about that. How would you have a tuple as a key value? Because a tuple is a list. Okay. So, yeah, this next code here just creates a dictionary that mirrors what you're seeing on this website: description, part number, color, and they are different data types. Python will assume dynamically the type of each one. And if we print them out, sure enough, let's see, am I getting towards the end of this thing? Yes. Okay. Different elements in any way necessary. So what do we got here? We gather quantity, turn it into an integer. We multiply total sale, or we assign total sale equal to the quantity times the product list price from our dictionary that we created. And then free shipping was yes or no. Free shipping was a Boolean value in our dictionary here. Okay, so if product free shipping, and you don't have to say equals true. You don't have to say if it equals true. You just say if product free shipping. That is in and of itself, that is a Boolean statement. Then we set ship cost to 0, otherwise $9.95, and we print it out. So let's run that one. Enter sale quantity, 400 million. You ordered 20, which will cost $418 plus nothing for shipping because product free shipping is true. Okay. And then down here, I did not delete. I did not believe I entered. Yes, I left his code. This is kind of a homework assignment. If you guys want to not look at that and work on some Python, there's a homework assignment or an exercise built right into there. But I'm not gonna make that as an assignment per se. And then we've got some other stuff on dictionaries down here. Let's see what we got here. Interesting. For key, comma, value. Let's see what we got here. I don't think I need to run that. Let's see what we got here. I don't think I noticed these down here, these last two cells. Let's see what we got. For key, comma, value. Well, that's just, okay. That's just creating two variables in the same for loop because you always have a key value pair. Interesting. Offices.items. So it looks in the dictionary and returns from an items method. Okay. And then get rid of good old Eric. And we see that he is gone from the dictionary. Okay, so that's a dictionary, a key and a value. And it's much like a list or a tuple, only it has a meaningful index, which is important in a lot of applications, particularly when you're dealing with JSON or XML files. Because at their heart, that's really all JSON and XML is key value pairs that can be nested similarly to what you saw when I demoed my API when I made that call to the Google Maps API and the reviews, that stuff gets returned as a dictionary. So, a dictionary of lists, and each list is a list of dictionaries, and the syntax gets kind of confusing when they become embedded like that. But that's the way a lot of this data comes. It's not just good old simple COBOL data anymore. Okay, so I wanted to show you that to make sure that you've got it. So now strings, how to operate on individual strings like name or address or whatever. You've got that notebook in there, but you've seen most of that already, so I didn't want to bother with going through it manually. Let me close this one out. Oop. Checkpoint, close and halt. Okay, so nobody else is going. So let me think of what else I wanted to show you that I was messing around with. Real quick. Yeah, strings and dictionaries. Okay. I'm trying to remember if I don't think any of this is new. Although I'm going to be adding to this data frame wrangling. I'm starting to see lots of places where when I'm goofing around with this stuff, I need a fresh example. Like I'm always telling you, I never code this stuff up from memory. I'm always looking at a good example of how to get something to work, and then I just type in my own variable names. So yeah, I'm starting to run into all kinds of ways I want to expand this data frame wrangling. Laura, you had asked for practice wrangling data frames. I'm going to show you a tutorial I ran into, and then I want to talk to the group about that. But we got to get everybody through the clean data, which the current assignment, the data analysis notebook assignment. There's no wrangling in that. You can download pristine data and just run some statistics and run some graphs. But I did want you guys to wrangle a data frame and then not necessarily worry about what you do with it, but go through the exercise to clean something. Let me hop over to my workshop here. I got to organize my notebooks directory. This is getting out of control. Look at all these notebooks. Good grief. I'm a digital hoarder. I'm the cat lady that they come to the door and she can't even open the door because there's so much stuff in the house and 19 cats. And I'm the Python programming equivalent of hoarders buried for life. Yeah, here's that canned inventory. That was fun. All right, now what was I working on? I know I was doing Did I call it a DAAT thing? Let me Oh yeah, here's another. This is an interesting one. I'll post this under projects, which is the only thing I could think of that are these specialized applications of Python. So I'll post this in the classroom. But I found a word cloud generator, and I want to say that I got it working. And you need one. Did I already put this? This is looking awful familiar. Did I already put this one in there? Under projects. Word cloud generator and WineMag. Yeah, I did already. We haven't talked about this, have we? I worked on a bunch of notebooks and uploaded them. We have not talked about this. Thank you, Laura.
I don't think so.
Yeah. Okay. So yeah, I thought there were some more stuff that I'd put on here to show you guys, but this WineMag data is wine magazine reviews of different wines, and it is not small. It's like 50 megs. So I don't know if you want to download that some other time, or I guess that's not as big of a file as it used to be. I remember when 50 meg file would be like overnight. So yeah, a word cloud, and this library I got from another great tutorial site called Data Camp that works really well. So if we do all of our import statements, and I thought I printed out what the stop words were in here somewhere. I think I do, yeah, because it's importing this thing called stop words from word cloud, which I thought, I know what stop words are is don't use this in your analysis, like I, you, if, the, you don't want to put those in a word cloud. So that does all my imports, and then I read in my reviews, and I'm using my notation for where that file is over in my data directory. And yes, I think these are might be Seaborn that does a lot of warnings that we can turn off, we can ignore. Okay, so if we look at the top of this, what we're doing, if I can back up, a word cloud, you probably have seen, it's like a square with a bunch of words in it, and it reflects the frequency of use of words in text, and that can be all of Wikipedia, or it can be a few hundred reviews in Google, or whatever it could be student reviews for you guys in CAE. I don't know if anybody's word cloud and stuff. Seems like we've kind of talked about word cloud way back at the beginning, but just real I didn't have a good notebook for you to use. So anyway, this is wine reviews that we're going to do so we got a data frame with lots of columns in it that we don't necessarily need, but description. This is where you can this is ripe and fruity wine that is smooth with an after finish of a blush of apricots. And I don't know, these people that write that write wine tasting stuff, they've just got to come up with so many superlatives. But that's what we'll be analyzing, is the description of a wine from this wine magazine data set. And of course, we have, how well they scored in their review. We've got the region of the country. Willamette Valley is out in Oregon, where I-5 shoots up the middle of Oregon, and it is fantastic if you've ever been out there. I'm sure there's a what do you call it? Finger Lakes region in there somewhere. In fact, before we move on, I want to know the unique values of region 1. DF bracket quote RE tab Gen 1 dot unique. Just out of curiosity. And we need another close print. What did I do wrong? Whoop, need a square bracket. Okay, print. Data frame region 1, column region 1, yeah, dot unique. Yeah, that should run now. Right? Shouldn't that run?
One way to find out.
I know, but I can be Socratic if I. Oh, there's too many values to display. Darn, there's got to be a set max values, but I won't. I don't want to slow you guys down anymore. Anyway, so this prints out the the basic characteristics of the data set using some of these data frame methods. Like the dot length of variety dot data frame dot variety. That's I'm just goofing at the syntax there, guys. Data frame dot, because these are columns in the data frame. So we're not using the open bracket. I'm going to have to do some more looking at that. Hang on just a sec, making another note. Okay. So yeah, that's going through the columns and telling you more about the data. And then just looking at these columns. So that gets you a little bit more about description. And then remember there's a group by function. I did put that in the pandas pivot tables. Yeah. You can group stuff together, kind of like a pivot table. So that's what we're doing there. And we're grabbing all the stuff from each country. Argentina, Armenian wine, wow. And then we are sorting by points from ascending equals false. So we're going from good wine to worst wine. And then pretty sure this is a bar chart. Yeah, just shows you the prevalence of wine by country. Of course, U.S., France, Italy, Spain, just like you'd think. And then we get into the word cloud part. So we're setting a variable text to be equal to the first description in the data frame, and then we call our word cloud library generate method, passing that single review. This is the text of one review. And then, of course, we have to use, I believe it's matplotlib to format things. Remember, matplotlib underlies a lot of import. Yeah, pyplot, matplotlib pyplot as PLT. Yep. Matplotlib underlies a lot of these things that you run into. So that's where the PLT commands come in. And we generate, this is the words from one review, but then we can pass all the reviews, and here we're setting up the next word cloud, which actually uses most stuff here. and so that's basically all of your did we had to reset text here somewhere. Hang on a sec. I'm not liking what I'm seeing, but I don't want to slow down too much here. We set text to being one review. And then we generated a word cloud in this cell, and that generated that first one. What I'm not seeing is where I changed text. Still looks like it would just be one review. I'm going to have to go back in here and see what I'm looking at, because it changed. No, there's something different. The dot description isn't. I don't believe that's one review. I'm going to have to go back and do some diagnostics and look at exactly what I'm looking at. Because this, what changed was this max words to render this second word cloud. Anyway, I'll figure it out. And you can save a word cloud, and in fact, you can save pretty much any of these Seaborn, any of these things. You can save them to file as a JPEG or a PNG, and then use them in subsequent tools like PowerPoint or whatever. So yeah, that wrote that out, and it's now in my temp folder up here, Python TMP first review PNG. So there's your image saved out to hard drive, and it's being viewed in Notebook, but it's just a good old PNG. And then there are blank words in combination. Yeah, there's 31 million words in all the reviews. It's a big file. So anyway, I added this one. I wanted to see what stop words were before we mess with it. And this is words that that the word cloud generator won't use. A lot of pronouns, a lot of connecting words to get rid of, which you might see in some text. So you can always change that for your application, depending on if it's web traffic and you're pulling reviews out, or surveys or whatever. If there's words like, I don't know, mission that you don't care about at CAE, things like that, you can pull those out so it doesn't skew the data too weird. And then you can update. Yeah, you can update. So we're going to get rid of that, and then we're going to run it again. And I'm just going to yap for a little bit longer, and then I'm going to let you guys either play with this stuff or it's taking forever. I got to wonder if I broke something. Nope. Just took a little while. And now that we've modified stop words, remember drink now, wine, flavors? Were those up here? Drink now, wine, flavors. No, I don't see them up here, but we got rid of them. And now we have finish palette. Show hint blend. It shows a blended hint up my nose. All right, good stuff. So that's a word cloud. It's another kind of visualization. I got one more thing I want to show you, and then I'll let you guys just get to work. Go ahead, Damon.
Hey, Don, of course. Does the size of the words kind of depend on the frequency that they showed up at all?
Yeah, the more, generally speaking, the more frequently a word shows up, the larger it will be, and the algorithm moves them towards the center of the diagram, kind of to make them more prevalent.
Okay.
Yeah, and if you look at the documentation for this library, what did we call it when we imported it? Import from the word cloud library. We imported these different modules. I'm sure there's a word cloud document out there. Python that would tell you the parameters and stuff, and you can manipulate the color palette. You can limit the number of words to put in the word cloud. I think that's what that 100 was, is max words in the word cloud is 100. Word cloud for Python documentation. That's it right there. So this is the documentation for that library, and it'll there's examples and syntax and whatnot, all available at a Google. There's one more thing I was dorking around with. I wanted to show you guys, and then like I said, if you just knock out that Python project for me, so we can move on. I want to do a classifier using scikit-learn on Thursday, and just a real simple linear regression model. So let me go up here to Python notebooks. And I want to say I did not name it a DAAT, what do you call it? But I might have. Let me look real quick here. I have remnants of that canning project, Xander can. I got like 5 files from that thing. Such a pack rat. No. Although we could. People talk about web scraping like, oh yeah, just scrape some data off the web. That stuff looks complicated. Word cloud generator, data for no. Data cleaning tutorial. Here's 2 things. That and the data frame query method. So Laura, here's a tutorial I got working that I found at Real Python. And it has some of the stuff that I put in the data frame wrangling common tasks, but there's some pretty complex math in here that you guys might be able to take advantage of. But you can pretty much walk through the tutorial. But I wanted to show you some of this code. It's like when you've got a complex, goofed up column value like 1879. Oh, but in square brackets 1878. What does that mean? That's not anything you can look at. Some of these things, 1939 and 38 through 54. A human mind might be able to make sense of values like that in a column for data publication, but yeah, Python can't. Anyway, like I said, this reminded me when Laura said I need help, I need practice. I got this working so that you could see some conversions. But like, yeah, they start. I'd have to go through line by line and what are you doing there? But it gives you some techniques for changing characters to another character, dropping characters within a column, so that it comes out a lot more clean. Um, but there's some pretty good code samples in here. But a lot of the stuff, I think he was just showing off, like cleaning author name, which is pretty goofy in this in this data set, is some pretty complex code. He creates a function, clean author names, um, and then runs it on the data frame down here, and it does clean them up. But anyway, it just kind of shows you how we've been in Python kindergarten compared to some of these gurus out here. And this one cleans up the title, and it'll give you uh, some good examples of wrangling individual cell values. But once you get an individual column that you want to mess with, and you can come up with the rules for getting rid of things, you could write these sort of methods yourself. And oh yeah, messing around with the place of publication. So anyway, yeah, I will post this data cleaning tutorial, and run through it. If data cleaning in Python is in your future, it's extensive, and it took me a few hours to get it to work, because I'm cutting and pasting this stuff a lot of times from the internet, and troubleshooting, and I'll get errors, and like the internet, you get what you pay for. But yeah, some no kidding wrangling, and then some good links at the bottom. So I will post that. File, close, and halt under projects. But then I wanted to show you a method to copy. Where'd it go? Data frame query method. We had been creating data frames by using kind of the data frame open bracket notation, and I found what I think is a better way to do it. And that is like, okay, so I'm importing pandas, and I'm importing seaborn, just to get my favorite data set in the whole wide world, penguins. So I load that data set into df. And then here's another command that I wanted to show you guys that took me a minute or three to Google, and that is dropping null values. When Dr. Ellis was doing his pandas workshop, I asked him, philosophically, what do you do with blank values, with null values? Because to me, that's an invalid thing. So, and it will make some of these things error. It will make some of these plots and calculations choke if you have null values. So you don't want to make it a 0. If it's like a flipper length, you don't want to say that you saw a penguin with 0 length flippers, because that outlier will mess up all your other data. So I just dropped the nulls from this data frame dot dropna method drops nulls, and then you can pass it some parameters that tell you what you want to do. Axis equals 0, I want to say, is from every row. Pretty sure. And how is drop everything. Drop every row that has a null value in it, and consider that a incomplete observation by the naturalist that was out there on these islands looking at penguins. So that gets rid of all my null values. But then you can create a data frame using this data frame dot query, and then inside of the query, you can use any valid comparison operator. The species is a column name, equals, and then you use the literal string value. But it also works to say like species equals Adelaide and build depth is greater than 50. So you would subset the data frame such that it would only grab a certain species and a certain bill length or whatever. So if you wanted to subset the data and bring it over into another data frame in one line of code, this is it, data frame.query. I stumbled into that when I was geeking out on Python this weekend. So I created 3 data frames with no nulls for each of the 3 species of penguins in our data set. And then I ran into, you guys might have heard of a kernel density plot. Does that ring a bell to you experienced analysts? I was taking my Seaborn tutorial, and the guy threw this up there as a way to show differences in the same continuous variable for different categories in the same. Well, actually, you can do it on one. You could do it on one category. It's similar to a box plot. The darker the color is the average value. So it's kind of like a histogram. Yeah, that's better. It's like a histogram, but it shows you more because it shows it on both axes, and then you can combine 3 different categorical variables on the same kernel density plot. So that's Seaborn notation. We're using your X variable, then your Y variable. So I'm using build length, then build depth from the Adelaide data frame for the first portion of this, making it red, and then I make the chin straps are blue, and the Gen 2 penguins are green. And so what this does is it shows you the highest density of bill length by bill depth by species. So we can see that the average bill length and depth of a chin strap penguin is much longer, 50 something millimeters, than our little red Adelaide penguins, which are the cutest little penguin, by the way, Adelaide penguins. And then what do you call it? Gen toes are longer, but they've got a much less deep bill. And then you see within the kernel density plot, you're seeing two peaks. I would have to assume that that's by sex, that the males tend to average a certain size and the females tend to average a certain size. And that's why you're seeing within the same species, you see two densities, kernel density plot. So anyway, thought that might be something you might want to look into. And yeah, this cat plot, I I hadn't used that before, so I wanted to mess with that using the same data set. So I did, and this groups using that hue. You know, you got X, Y, and then hue lets you kind of bring in a third variable. So I have the different islands that they live on, but then we see the different colors or species. So apparently you don't have anything but Adelaide penguins on Torgerson Island, and you don't have gentoes anywhere but Biscoe Island, and you don't have chin straps anywhere but Dream Island. So I thought that was pretty good exploratory data analysis. Is this interesting enough for me to post in the classroom?
Yeah.
Yeah. I will. Data frame query method. What else can I call it? Data frame query method. And KDE.
Don, I had a question about that kernel density plot. You said those were categorical variables. Is that right?
No, it's they're each one of these. Let me. Did I run all of this all together? I did, didn't I? Let me comment out. I'll just edit split cell. Arg. Yes, that's not defined. Did I not run this dang thing? Hang on. Run all.
I take it down.
Cell run all. Bam, 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 bam. Oh, and there's our warnings. Arg. You can turn that off. But you see, here's Damon. This is one species, because I broke the species out of the data frame, you know. So this red plot that I just drew is only for Adelaide penguins, but it's for continuous variables. Bill length and bill depth are both continuous variables. Yeah. So I'm trying to think.
That makes sense.
And if I wanted to, run a histogram on that, help me out. Edit. No, just a new cell. If I wanted to do a histogram of that, what's the what's the histogram in Seaborn?
I'm not sure.
Histplot. Histplot. There you go. So I think what I was thinking I could do is basically cut and paste this and just rename the plot. We'll see if that works. Histplot. sns.histplot. Did I misspell that? It's right there. It does not like the word histplot.
Was it histoplot with a O?
We will soon find out. What did I do wrong? Histplot.
And you don't have to say Seaborn because you labeled Seaborn as SNS.
As SNS, right? Yeah. Okay. We could, because it's telling me Seaborn, so it knows what SNS is. Has no attribute histplot. Could that be old? Seaborn 11? No, that's Anyway, let me kill that cell so it doesn't error on you guys. Cut. But that shows you how when you run it with one type of. In fact, we don't even need. No, that's just that's build length and build depth. We could do it for the entire data frame. In fact, let's do that. If we do this DF, which still exists, color, change the color, change it to I think this works. And you got to go to the documentation to see all of these different I don't know why that happened. Oh, yellow. That's what I get. That's what I get. Trying to be fancy. I don't know the proper syntax that CMap parameter is expecting. So blam. Now that's all of the penguins, and you can kind of see how it kind of mirrored the other one. You know what I mean? Where it was broken down by 3 different species in 3 different colors. So you can run a KDE on all build length and build depths, and it starts to show you there's something going on here, right? When you've got continuous data and you start to see it cluster like that, which is another type of machine learning that hopefully we'll get to on Thursday. There's got to be something that explains that, you would think, right? And I think when we go back and we look at the data, we find that it was Adelaide penguins, Gento penguins, and chinstraps that causes these clusters. Where I don't know that a histogram would find that, but that's also going on my list. Show a histogram. And I got to figure out what in the heck I know. Against a KDE plot for all penguins. Okay. So I want to merge these 2 back together.
Hey, Don, last question.
Sure.
How does it know that to put all of those in the same graph? Are you connecting those in any way, or it just knows to?
No, I think when you set up these plots, if you don't show it and then go back and set up another plot, they build on each other. And there's another command. There's another command in here that you need to look out for. No, it's not in this one. I think it's in my Seaborn tutorial I'm going through. There's a way to get matplotlib. You don't need plt.show. It's like matplotlib inline equals true or something like that, where you don't have to explicitly say show the plot. But again, I'm still learning. But yeah, these things. Inside, it's creating an object, and it's layering this stuff on top. But as soon as we run it, it goes away. Like I want to say, if you need to take a break, we haven't taken a break, did we? We didn't really take a 10-15 break, did we?
I don't think so.
I don't think we did. I can tell that we didn't take a 10-15 break. Let's see here. I want to test that theory, that hypothesis. So I want to add a cell, and I want to do one of these things. But I want to say, let's use a different variables. Let's use, and oh, here's another handy. If you got column names that are not super easy to remember, just do a dot head and go up to there and copy them and paste them. So we're going to do body mass gram, and then I want to do, I'm curious what happens if we do a categorical variable. And then run that. I'm curious if I'm going to blow it up. Could not convert string to float female. Oh yeah, it's trying to do a KDE on a categorical variable. I'd have to figure out a different way to do it. I just wanted to do different variables, but they have to be continuous. What were we using? Bills? Yeah, let's go flipper length. Yeah, flipper length versus their body mass. There. So these are two continuous variables. So bam. So I ran that. And this other stuff went away. Damon, see the layers? It didn't layer this new thing on top of that one because I ran it and displayed it. And it seems to almost like when you say, you reassign a value to a variable, it seems like these sns.kd plot commands are building a plot object, but they don't overwrite. They don't start from scratch until you actually display the chart. But I'm gonna have to.
Okay, that makes sense. I was just curious because we were like reestablishing the axis labels again and whatnot, but maybe it's just overwriting that too or layering that too.
Because you're right. If you don't explicitly go back and change some things that you had set before, that those parameters don't carry forward from graphic to graphic to graphic. It's like each chart is an object, and when you display it, it goes, I'm done, and gets ready for the next build session of that object. But I'm gonna have to read up on exactly how that happens and why. Okay, so there's some of that for you. And I wanted to call this query method in KDE, and I gotta put my little naming convention on there to assure myself that I have quality controlled it. rename that. Okay, so I'll upload both of those. The data wrangling exercise, which was extremely complex. I won't come up with something like that. But that'll be the next thing, Laura, is we've been working with clean data so far. We haven't really done any wrangling other than you have imposed on yourself. So I'll find a not too shabby but wrong data set. It's not too big or anything like that, but it has some weirdness about it. And I'll say, and I'll assign what to wrangle in it, and then if you know, if you want to take it from there, great. But I want to get. I think I need to provide some guardrails so the folks know when they're done, because I know I wind up just down these rabbit holes. So I'll do what I can to keep you guys out of the rabbit holes. But y'all that haven't gone, y'all that have not gone, all y'all which have not gone, please go on Thursday. And between now and then, not this afternoon, tomorrow, sometime tomorrow, if you want to get together, great. Or you can email me questions and I can work on it, you know, tonight or early in the morning tomorrow or whatever. But let's get these Python projects of yours complete, and you do your, you know, do your presentation, and we'll move on to that data wrangling. And I'll also work on linear regression and a simple classifier in Python for Thursday. Okay? Questions? Gone once? Go ahead. Somebody unmuted.
I was just going to say I don't have any.
Oh, gone twice? 3 times? Okay, guys. Please use the rest of the time to mess with this stuff we've been working on. And if you have anything that you want to discuss personally, you know, one-on-one, you know where to find me, and you know I'm here for you, right? You know that, right, Laura? Thank you. Yes, Don, you're a good boy. You're here for us, Don. Good boy. Okay, guys, I'll see you Thursday morning at 8:30.
Thanks, Don.